the next concept from this topic, that is internal energy. What is internal energy? This concept is also very important for the competitive type of exam. Now, what is internal energy? Now, here if we consider one of the system, for example, here this container is taken here for thermodynamic study. Here system is considered. Okay. Now, for this system, definite amount of energy is present, that is called as internal energy. That means here there are different types of energy that is related with the system. Different types of energies are related with the system, and depending upon different types of system, different energies are present. Okay, so here internal energy, that is the summation of all type of energies present within the system. So here we can consider here internal energy, that is denoted by capital U. And mostly in all the system, two types of energies are present: kinetic energy and potential energy. And also there are so many types of energy: rotational energy, vibrational energy, electronic energy, and sum of all these types of energy, that is nothing but internal energy of the system. Kinetic energy plus potential energy, vibrational energy, rotational energy, electronic energy, we can do the summation of all type of energy, then we'll obtain here internal energy of the system. That means internal energy related with the different types of energies present within the system. So here if we consider this definition, then according to the definition, it is seen that internal energy, that is capital U, is a state function, because internal energy depends upon initial state of the system and final state of the system. That depends upon initial state and final state of the system. Then only we can find out the internal energy of any system. Because here internal energy is the summation of all type of energy, and that is very complicated. So whatever initial energy is there, whatever final energy is there for that system, and the difference give us change in internal energy, that is delta U is equal to U2 minus U1. Internal energy of the final state minus internal energy of the initial state, that difference give us change in internal energy. And so internal energy is a state function, and also whatever changes occurs within that system, that depends upon mass present in the system. Whatever mass is present in the system, depending upon changes occurs, depending upon final state is obtained. And so internal energy is an extensive property. Internal energy is an extensive property. Why? Because here different types of energy that depends upon mass present within the system. And so here internal energy, that is the extensive property. Internal energy is a state function. So depending upon this, MCQs can be asked. What is internal energy? Whether internal energy is a state function, whether internal energy is a extensive or intensive property. Internal energy is a state function, internal energy is a extensive property. So depending upon this internal energy, first law of thermodynamics is given. So let us consider here what are the statements for first law of thermodynamics. Okay, there are different types of statements are there for this first law of thermodynamics, but one statement is very important. What is that statement? Energy can neither be created nor be destroyed, but that can be converted from one form to another form. This statement is very important. What is that statement? Energy can neither be created nor be destroyed, but it can be converted it can be converted from one form to another form. This is one of the statement of first law of thermodynamics. Energy can neither be created nor be destroyed. That means here energy cannot be created. It cannot be prepared by using any machine. So there is only exchange of energy takes place. That means one form of energy can be converted into another form. For example, chemical energy is converted into electrical energy. Electrical energy can be converted into chemical energy. So there is exchange of energy takes place, but energy can neither be created and we cannot destroy any type of energy. We can change, but we cannot destroy. For example, here suppose this is the container, okay, this is the system. Now here the energy provided to this system is the E1 energy. Now here this system releases energy to the surrounding. This is the E2 energy. That means one form of energy is provided to this system. One form of energy is provided to this system, and system also releases energy to the surrounding. This is the surrounding. Suppose here E1 energy is provided to this system. Here whatever changes occurs within this system also releases energy to the surrounding. But here E1 and E2, they are the different forms of energy. This form of energy should be different than the E2 type. That means here energy can be exchanged, but here preparation of energy, formation of energy by using any machine is not possible. And here whatever energy is formed, that is only the conversion, that is not the formation, that is only conversion of one form of energy. And also we cannot destroy these energies. We cannot destroy these energies. We cannot form these types of energy, but there is conversion of one form of energy into another form of energy takes place. That means here total energy of the universe remains constant. Universe is an isolated system because there is exchange of energy between system and surrounding takes place. So the total energy of the universe remains constant. There is exchange between energy takes place between system and surrounding. So universe is said to be an isolated system. There is no any perpetual machine which can form any type of energy. There is no any perpetual machine which can work without consuming energy. So one form of energy is converted into another form of energy, but energy cannot be created, energy cannot be destroyed. So this is the simple way of first law of thermodynamics. But here how to express this first law of thermodynamics in mathematical form, that we'll see here. Now here we know that whenever we are considering any system, then here there is change in internal energy takes place. When system absorbs energy from the surrounding and when system releases energy to the surrounding, then there is change in internal energy takes place. Then only the conversion of one form of energy into another form of energy is possible. Okay, so here there is change, indirectly we can say that there is change in internal energy takes place. And also one thing is very important. First only we have defined what is chemical thermodynamics. It is the branch of physical chemistry which deals with interconversion of energy between system and surrounding, but that energy conversion is always takes place in the form of work and heat. Work and heat. There is exchange of work as well as heat takes place, and then only the formation of internal energy, change in internal energy is observed. And so here delta U is equal to Q plus W. This is the mathematical expression. This is the mathematical expression for the first law of thermodynamics. Now here one thing is very important. If we see the first law of thermodynamics according to physics, then in physics here minus sign is there. Delta U is equal to, in physics how we are writing, delta U is equal to delta Q plus delta W. and minus delta W. Okay, but here in chemistry we are using delta U is equal to Q plus W. Why? That is very important, because here we have to also see what is the sign convention when work is done by the system, or when work is done by the system or on the system. So that is very important. Sign convention is very important, but mathematical expression we have to write this only. There is no change in this sign. Q plus W only, or we can write Q is equal to delta U minus W. Now here how this happens, that we'll see here. Why this expression is correct, that we'll see here by one of the simple experiment. For example, consider here one of the container. Okay, so here in this container, suppose water is taken. Okay, so here this water is having its own internal energy. Okay, now suppose heat is supplied here. Here piston is placed over the surface of water. Now here some heat is supplied to the system, given to the system. Heat, that is Q, that is given to the system. Now what happens when heat is given to the system? Obviously the volume of this water increases. When heat is given to this water, then volume increases, and due to volume increases, here what happens? Expansion takes place. Okay, expansion takes place. That means there is change in volume observed. Initially suppose V1 is the volume, and here change in volume observed, so final volume is V2. That means there is change in volume observed, that is delta V. That means here what happens? Expansion takes place. Expansion takes place means here what happens? Whatever vapors goes outside to the surrounding, that is due to the system. So we can say that system performs work on the surrounding. System performs work on the surrounding. That is the change in internal energy delta U. Change in internal energy, because here water is having its own energy. When heat is given, internal energy is changed, and due to that volume change is observed. So change in internal energy is due to the heat supplied to the system and plus work performed. But here one thing is what? Whatever work is performed, that is by the system. That is by the system and not on the system, because here expansion takes place. And so we have to consider here sign convention. That is very important. When heat is provided, what type of work is performed, whether that is by the system or whether that is on the system. So this is first law of thermodynamics, delta U is equal to Q plus W, and also by this small experiment we have seen that how delta U is equal to Q plus W. Okay, so here let us consider what are the sign convention. What are the sign convention? So here for example, here consider this is the system, and here surrounding. Outside the system, the part of universe, that is called as surrounding. Now here heat is exchanged in the form of heat and work. Okay, so here for example, here heat is absorbed by the system. Heat is provided to system. Heat is absorbed by the system from the surrounding. So we are considering here sign for Q, that is plus. Here heat is absorbed by the system, gained by the system from the surrounding, so plus Q. Okay, so plus Q. Now here if heat is released from the system to the surrounding, then sign for heat is minus. When system releases energy, gives energy, then here minus Q is considered. Plus Q, heat is absorbed by the system, it is gained by the system from the surrounding, because there is exchange between heat, energy or work between system and surrounding only. So here system absorbs energy, that is from surrounding, so here plus Q. Here heat releases energy to the surrounding, so minus Q. Now here same way, if work is performed by the surrounding on the system, then that is plus W. When work is performed by the surrounding on the system, that is plus W. Sign for work is always plus when work is performed by the surrounding on the system. And here when system performs work on the surrounding, then sign of work is always negative. Why this happens? Because when work is performed by the system on the surrounding, then expansion takes place. Okay. Here when expansion takes place within the system, then work is performed by the system on the surrounding, then work is minus W. And when compression takes place, then here work is performed by the surrounding on the system. So compression type of work is always positive. Compression type of work is always positive. Expansion type of work is always negative. Why that is negative? Because that work is done by the small amount of system on the bigger amount of surrounding, so that is negative. And here when bigger quantity of universe that does work on the small thing, so that is the system, so that work is positive. Work is done by the surrounding on the system plus W. Heat is given by the surrounding to the system plus Q. When heat is released from system to the surrounding, it is negative. When work is performed by the system on the surrounding, work is negative. And when work is done by the system on the surrounding, it is always expansion type of work. And when work is performed by the surrounding on the system, it is always compression type of work. This is negative work and this is positive work. And these are the sign convention, and this is very important. Okay, so we'll stop here. Thank you.